Today's lesson, a summary on acid, bases, and salts. This is the unit number 7 in grade 11. So the examples for acid, bases, and salts. The lime juice, you know that. Giovanni actually a salt. Antacid tablets. These are the bases. Milk of magnesia, for example, for base, and toothpaste is a base, and vinegar is an example for acid. Salt is a salt, again lime is actually calcium oxide, or we say quicklime, which is a base. Soap is considered as a base. Vitamin C tablets are acids. Saline solution is actually a salt. And when it comes to what is an acid, the definition of it, you know that the acids are the compounds that releases hydrogen ions in an aqueous medium. So when you dissolve acids in water, we say aqueous medium, this compound will release H plus ions. So any compounds which releases H plus ions, we say acids. And based on acids, when you concern as far as the acids are concerned, there are two types of acids. We say strong acids as well as the weak acids. Strong acids which release H plus ions by complete ionization. That means there is no remaining of compounds after they are dissolved in water. In aqueous medium, you don't find any compounds here. Each and every molecule are dissociated or ionized completely. So you don't find any of HCl compound after they become ionized. So we say, for example, we say there are 5 molecules of HCl, you will find 5 H plus ions and 5 chloride ions. That means complete ionization. Weak acids means release H plus ions by incomplete, or we say partial ionization. So you don't find the complete H plus ions. At the same time, there are remaining molecules of acids. These compounds may remain. So what are the examples for the strong acids? I forgot to say the strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Weak acids are acetic acid, carbonic acid, and phosphoric acids. And you know, in your labs, the acids are in concentrated form. So you will make it to dilute by how you add few drops of acids to water. So generally, the properties of acids are considered concerned. They are generally burns when they spill in skin, and they are corrosive when they contact with the metals, and the taste is a bit sour. And the reactions of the acids, you see that the magnesium and zinc, those in reactivity series, that the certain metals that give hydrogen gas when they react with acids. At the same time, the acids, when they react with limestones, carbonates, or bicarbonates, they release carbon dioxide. And you know that the acid-base reaction, that the acids, when they react with bases, they give the salt and water. So certain uses of some acids. So hydrochloric acid is important to make gelatin, and also it is used to remove the rust and also to make aqua regia. Sulfuric acid is also known as battery acid, so which is used in fertilizers and making paints, plastic, and detergents. They are used to dry gas. It's a very important point here. Acetic acids are commonly found in vinegar, so which is a weak acid, and they used to coagulate rubber. So acetic acid is very important to coagulate rubber, right? Rubber milk. So this is the CH3COOH is the chemical formula of acetic acid. So very important in paper industry and textile and photographic films too. And then the bases. So examples are here: milk of magnesia, toothpaste, and soap. At the same time, the quicklime, the calcium oxide. Ammonia is a basic gas, and these are the examples for bases: sodium hydroxide, potassium hydroxide, ammonium hydroxide, used in labs. What is a base? These are the compounds that release hydroxide ions or hydroxyl ions in aqueous medium. So the sodium hydroxide, when it is ionize, it becomes Na plus and OH minus. Strong bases means they release OH ions by complete ionization. That means no remaining of the compounds. Weak bases are the bases which release OH ions in incomplete partial ionization. That means you find OH ions, OH minus ions, as well as ammonium hydroxide molecules as well in the solution, in the medium. Generally, the properties of bases are concerned. They are slimy in texture and they react with acids. They give salt and water. The bases which dissolve in water, they are readily dissolved in water, are called as alkalis. So know that the sodium hydroxide, ammonium hydroxide are alkalis, whereas the magnesium hydroxide is not an alkalis. Remember that. Certain uses sodium hydroxide used in soap industries, and it is also used in lab as a strong base. And magnesium hydroxide is used as antacid in relieving gastritis, and also it is used in sugar industry. A very important point again is that the acid-base indicators identification. So the litmus test is the first indicator which is used. The litmus is used to differentiate acid and bases. You know that the blue litmus will turn to red with acids, red litmus paper will turn to blue with bases. Another indicator is phenolphthalein, where the phenolphthalein is colorless, which gives pink with base and colorless with acids. Another indicator which is methyl orange, it is orange in color itself, and then it turns to a red color with acid, and it turns to yellow with bases. But you cannot identify by using these indicators whether these are strong or acid base or acids or bases, whether they are strong or weak. Then we have to use pH indicators, where you can find the strength of the acid and base, whether they are strong or weak. So we have a pH scale. So 0 to 14, the range of it. 7 is considered as salt or the neutral. Below 7, the pH number below 7 are acids. Above 7 are called bases. So when it comes to closer to 0 to 1, we say it's a strong acids. Closer to 12 to 13, 14, we say strong bases. And this is, the neutral. And then the weak bases are between 8, 9, 10, the range of it. Weak acids are in the range of 4, 5, 6, generally the 5, 6, which is closer to 7. So you have the pH papers. These are the colors of the pH papers. When you immerse into a solution, it will give a color. So that color will specify the number. So based on the color, you get the number and you can get the idea of whether it's a strong or a weak base or acid. And the salts. Salts are actually, they are crystals. You know that they are made out of generally of ionic compounds. They are generally ionic compounds, and they are solids. They are readily soluble in water. They have a high melting and boiling points. So when these salts, how do you prepare salts in your lab? Reacting an acid with a base. So any acid and base reactions will give you a salt. These are the salts here. So based on when the strong acid is reacted with a strong base, you get a neutral salt. At the same time, when a strong acid is reacted with a weak base, you get an acidic salt. When there is a strong base is reacted with a weak acid, you get a basic salt. Certain uses. Sodium chloride is a salt which is used as a food flavor as well as a food preservative. Copper sulfate, which is blue in color, that is a crystal which is used to make Benedict solution in your lab. And also it is a fungicide as in agriculture, used as a fungicide to kill the fungus. And also it is important in electroplating and textile dyeing. What is neutralization? The definition of the neutralization is reacting of H plus ions and OH minus ions, H plus and OH minus reaction, which makes H2O molecule. So actually the neutralization reaction is a reaction between H plus ions and OH ions in aqueous medium, which gives a water molecule. So in this neutralization reaction, you know that the acidic and basic properties will disappear. So certain uses of acids and bases, In case of neutralization, milk of magnesia is a weak base which is used as to relieve the gastritis. And to reduce soil acidity, sometimes the quicklime, the base is used, that is to reduce where the condition of the soil is acid. And also in a bee sting, attack of bee sting, you know that it is acidic, you can use a base to neutralize it, either baking soda or limestone. A wasp sting, in case of wasp sting, it's a basic actually, you can use an acid to neutralize it. For example, you can use lime juice or vinegar. Thank you very much. This is a summary of acid, base, and salts.